Assalamualaikum warahmatullahi wabarakatuh. So today my group and I will present about yearly income classification. But first of all, let me introduce my group members. My group members consist of me, Nurhani Zahira, Siti Aisyah, Raina Auni Putri, Wan Aina Nabila, and also Nur Akila. So our first phase is searching the data. So we have retrieved our dataset from Kaggle, which is called Census. It shows an individual's annual income results from various factors such as education level, age, gender, occupation, and etc. This dataset contains information about the annual incomes of people from various different countries, but the majority is dominated by the United States. And our objective is to analyze the dataset and predict whether the income of an adult will exceed 50K per year or not by the classification model. So now let us take a look at the dataset. The dataset is called Census, which consists of 15 attributes and 48,842 instances. So we have 6 numeric attributes, which is age, final weight, education number, capital gain, capital loss, hours per week, and we have 8 nominal attributes, which is work class, education, marital status, occupation, relationship, race, sex, and native country. And lastly, our class label is income, which consists of 2 distinct labels. As you can see, we have a label of less than equal 50K and also greater than 50K. This dataset consists of several missing values. As we can see, under the attribute of work class, it consists of 6% missing values of 2,799. And another one, we can find a missing value under the attribute of occupation, also 6% of it. And lastly, we found that under native country, it has 2% of missing values. So let us take a look briefly at the dataset. As we can see, all these blank spaces are the missing values. And this is a brief visualization of all attributes. Now let's see the original accuracy of the data. I used the tree classifier of J48, and as we can see, by using the cross-validation testing mode of 10-fold cross-validation. So as we can see, the number of leaves are 696, the size of tree are 911, and the time taken to build the model of the original dataset is 3.83 seconds. As we can see, the original accuracy of the dataset is 86%, which means that there are 42,049 instances that are correctly classified, and 6,793 others are incorrectly classified, which indicates 13% of incorrect accuracy. So how are we going to handle this data? It will be explained by other members after this. Thank you.
Data understanding.
So next is to identify attributes that have missing values. So we can see here age doesn't have missing values, but work class, occupation, and also native country has missing values. So method to handle with these missing values is by using remove with values filter. So we have to edit the properties. So attribute index change to 2 for work class, invert selection to true, match missing values to true, and this is so that it will detect only missing values and remove only missing values. So nominal indices, we let it blank, okay, and apply. So repeat the same step for occupation and native country. So occupation is 7, apply, and native country is 14. This delete. Okay, and apply. So here we can see that all the missing values has become 0. So that's mean that it has removed the missing values. So that's all for the missing values. Next is to identify attributes that contain noise. So these methods to identify outliers and extreme value is by using interquartile range filter. So interquartile range filter, apply. And we can see here there is two new attributes, which is outlier and extreme value. So to remove outlier, here the value yes here is the amount of outliers that is suggested to be removed. So we can remove this value by using remove with values filter that we used before. So remove with values, change the attributes to 16 for outlier, and numeric indices change to 2, so that it will remove the yes value. So OK and apply. So repeat the same step for extreme value, which is 17. OK and apply. So we can see here the yes value has become 0 for both. So that's mean that it has removed the outliers. So next, to identify the attributes that contain outliers is by using interquartile range, and detection per attribute is changed to true. Click on OK and apply. So here we can see the attributes that contain outlier, which is age, final weight, education, capital gain, capital loss, and hours per week. So that's it for noise data. And next I will show the graph representation for all attributes. So here is the graph representation for all attributes. And last but not least, I will show the data after done with the data cleaning. So here is the data. So that is all from me. Thank you.
Data transformation.
Okay, now we proceed to data transformation. So basically data transformation is to smooth and reduce noises, and also we can do the normalization in this section. So first we look at the age. We got a numeric data type, and also for the hour per week we got a numeric data type. We want to change this numeric data type into a categorical data. To change numeric data type into categorical data, we choose discretized method. We go to supervise and then use discretized method, and then at these properties we change it the attribute indices 1 and 13, because age at attribute 1 and hour per week at attribute 13. So this bit change it to true, and we also use equal frequency binding. Okay, and then apply. So now we can see the data type change into a nominal, and it has a label. Also same goes to hour per week, change both. So next we want to change the label name. So to change the label name, we choose rename nominal value method. So here at the select attribute 1 and 13, so at the value replacement, this is the code. So for the age, label 1 I want to name it amateur, label 2 expert, and for the hour per week, label 1 want to change it into less than equal to 5 days, and for label 2 more than 5 days. So that is good, and then put it at value replacement. Okay, and then apply. So we can see the label name changed to amateur, expert, and hour per week changed to less than equal to 5 days and more than 5 days. So next we want to do a normalization, but before we do the normalization, we check the accuracy and the time taken to run the data. So we use J48 start. So we can see here the time taken to build a model is 1.13 seconds, and the accuracy is 84.2681. So next we do a normalize. Go to normalize method, and then change normalize to true. Okay, and then apply. So go back to classify and do the same method J48 again. This is because we want to compare the time taken to run the data and also check the accuracy. So we can look here, the time taken after we normalize is 0.88 seconds. So the accuracy is still the same, but the time taken is much more faster than before. So next, we want to merge a value. For example, I want to merge in attribute 2, label 2, 4, 5 all together into the government, label 3, 6 into self-employee, and so on. So we can see here at the level attribute 2, this level 2, level 4 and 5 is under government, so we can merge it into the government label. So I show you how to merge the label. We choose merge many value and then go to this attribute 2, and the label we want to change it into government. The label is 2, 4 and 5. 2, 4 and 5. Okay, and then apply. So we can see here there are new label in here, and all the 3 label before has been merged into the government label. So we can do the same step for self-employed, income, and also for the rest of this. So last but not least, we want to go to work class. We want to remove no income. So to remove this label, we choose instant and remove with value. So in the attribute 2, nominal indices is the label, so 4, and modify header we change it to true because we want to delete the header also. Select OK and then apply. So you go to class, the label no income has been removed. So last, we need to save the data that has been normalized. So save, input data normalized, and then save. Now we can go to our file. So data normalized is right here, so we can open it again. So here the data that has been normalized. Thank you.
Data classification.
Next phase is going to be the model development and evaluation, and we are using decision tree classification with J48 classifier as it had the highest accuracy among the others. Now I'm going to proceed with the demonstration. First thing, I'm going to load the normalized dataset, and under classify tab I'm going to choose the classifier J48, and I'm going to set the defaults into 10 under cross-validation method. With the output predictions, I'm going to change to plan test as I'm going to predict the value by the model, and then the accuracy will be 84.0821 with the conversion matrix right there, and then that is the training set of cross-validation with 10 folds, and the number of leaves would be 377, and the size of the tree would be 527, and that is the predictions on the test data. And then next would be I'm going to test with 20 folds, and the option is going to be the same, and I'm just going to click start and wait for 20 folds, and the accuracy will be 84.2493, and that is the confusion matrix. And as you can see, the 20 folds has higher accuracy compared to 10 folds. Next, I'm going to test the percentage split with 70% training set and 30% of test set, and then the accuracy will be 83.8905, and that is the confusion matrix. And then we have the training set, which is right there, and then that is the predictions on test split, and then the total number of instances of test set would be 30% of our data set, which is 10,230. And next I'm going to do the 90% percentage split, and the accuracy will be 84.4575, and that is the confusion matrix, and the total number of instances of the test set would be 10% of our data set, which is 3410. And as you can see, it has the highest percentage compared to the others. So 90% percentage split is a better method. And from this confusion matrix, we can see that the false negative of 169 instances of class income with less than or equal to 50k have been assigned to class income more than 50k, while the false positive of 361 instances of class income with more than 50k have been assigned to class income with less than or equal to 50k. So the false negative would be 169, the false positive would be 361 instances. And next, I'm going to show you the predictions on the test plate. And as you can see, the actual data is less than or equal to 50k for instance 1, and the predicted is less than or equal to 50k, and as you can see, there is no error as there is no plus symbol, and the prediction will be 0.77%. And then for the instance 3, we can see there is some error, which the actual data is more than 50k, but the predicted one is less than or equal to 50k, which is error predicted has been occur. And yeah, next I'm gonna visualize on the tree, which I'm gonna right click right there, and that is the tree. And that's all for the model development of full features.
Data reduction.
Alright, for data reduction is a process to reduce the volume of original data. It will improve accuracy, reduce overfitting, and reduce training time. First, we have the normalized dataset open in the Weka. Then we go to the select attribute tab. Among all the attribute evaluator, we choose to use CFS subset evaluator with best first method. And then as for the attribute selection mode, it doesn't matter if we choose full training set or cross validation, because it will provide us the same result. We try using full training set first. Okay, the results show the selected attribute are 1 for age, 5 for education num, 6 for marital status, 7 for occupation, 8 for relationship, and 13 for hours per week, total of 6 attribute. Let's see, if we use cross validation, it will produce the same result. The difference is how it displays the result. Okay, for full training, it will provide only the selection attribute, while cross-validation, it provides the percent of the attributes correlation to the class attribute. Okay, then we try using information gain evaluator as well to see if the selected attribute are ranked the same in InfoGain. And the results show that sex and education are ranked. Based on our reading on a research paper, sex and education are included as the most important feature. Attribute race, if we see attribute race and below, rank 0.00 something have lower rank value, which does not contribute that much in building our model. Okay, since education and education num has the same meaning, we decide to remove education num, as education attribute give more meaning than education num. Then we go to the pre-process tab to remove the unwanted attribute. Okay, we select all the unnecessary attribute, then we remove. Okay, from 17 attribute, now we get only 8 attribute including the class attribute. Then we try to classify to compare full feature dataset and reduce dataset. Same as before, we will use a J48 classifier with cross validation and percentage split. First, for cross validation, k equal to 10, the accuracy is 84.085, which is a little bit higher than before. Then for k equal to 20, the accuracy is 84.1026. Okay, now we use percentage split, 70% of training set. Okay, for percentage split 70% training set, the accuracy is 83.9198, which is about 0.03 higher. And then
And then for 90% training set, it has a highest accuracy ever, which is 84.9267. Okay, in this graph, it is shown that reduced set has better accuracy for percentage split and a little bit decrease in cross validation. As for cross validation k equal to 20, it is 0.1467 lower than full feature set, while for percentage split 70%, the accuracy of reduced set is about 0.03% higher than before. It is because cross-validation is suitable for small dataset, while percentage split is suitable for large dataset. The training time is indeed decreasing for both test options. Okay, what can I conclude here is that percentage split is the best method for large dataset, and the more the model learn, the better the accuracy is.